Hi students, welcome back in lecture number 10 of our course CNC machining programming. And in today's lecture, we will write a program for multiple turning cycle by using code G71. Now, as we know, G71 is a G code or a preparatory function, which means multiple turning cycle. And this code is also called as stock removal cycle in turning or roughing cycle. All these are same things. Let me write it. Stock removal cycle in turning or roughing cycle. Now, G71 cycle we will use in such cases when we are going to remove bulk material from the workpiece. And if we want to define it, we can also define this cycle as the G71 roughing cycle is used for rough material removal from a CNC lathe component. And after this roughing cycle, we always use finishing cycle. So we are also going to cover this G70 code in today's lecture, which means finishing cycle. Now let us move ahead. So this is the cylindrical workpiece which we are going to achieve in today's lecture. The total length of this workpiece is 70 mm. This is the outside diameter of this workpiece, 25 mm. And these are the respective diameters, 20, 17, then 15, and these are the respective lengths, 4, 12, 2, 12, 8 respectively. All these dimensions are shown here in mm. And this is the syntax for our turning cycle. And this syntax says that our G71, that is multiple turning cycle or roughing cycle, will be completed in 2 lines or 2 blocks. The first block or first line says G71 U value, R value. Then next block we have G71 P value, Q value, U value, W value, and F value. So these are the parameters which we must understand, that what are these parameters. Here U stands for depth of cut in x-axis, R is the relief or retraction amount, P and Q are the starting and finishing block of the profile respectively. After that, U and W are the finishing allowance in X and Z axis respectively. Then we have F, which is a feed rate. Let me explain you all these parameters in detailed way. So for this, let us refer this particular figure in order to understand our G71 cycle. This is our spindle, as we know. This is the chuck. This is our cutting tool or turning tool. And this is the workpiece that we have. I'm showing you the upper half portion of this workpiece. So this is our workpiece. Now let us understand our first parameter, that is U. U is the depth of cut in x-axis, as I explained you. Before that, we already know that at this particular center, we have our work coordinate system or origin. And here we know this will be our plus Z, and this is our plus X value. So depth of cut in x-axis. Now, in order to remove this much material from the workpiece, all this material, we need to specify depth of cut. So all these lines, horizontal lines, which are shown here, they are defining our depth of cut. In which axis? In x-axis. So this is our depth of cut in x-axis. Now, since there are two U here, U and U here, let me differentiate or segregate them. This is our U1, let us say, and this is our U2. So this U1 I'm taking here as depth of cut in x-axis. So every time the depth of cut which we are taking in x-axis is our U value, and it will be in radially direction. Radial direction means, let us say we want to remove 2 mm material from the workpiece, then U must be U1. Or suppose if we want to remove 3 mm material from the workpiece, then U will be 1.5. That is half value of our depth of cut. Whatever material we are going to remove from the workpiece, take the half value. So that's why I'm writing here radially direction. After that we have R, which is a relief or a retraction amount. Now let me explain you this. Let us say our cutting tool initially will be at this particular location, let us say. And now when the cutting tool or our turning tool is coming from this position to this position, and it is removing the material from the workpiece, let us say, and will be at this particular point. Now, after that, the tool is lifting up from this point to this point. So how much is this value? How much we are lifting the tool up when it is removing the material? Now we are lifting the tool up. This particular value is called as our retraction amount, which is shown here, this value R. After that, we know it will take the another depth of cut. Now the tool will be here from this point to this point. It will be reaching at this point, then removing the material from the workpiece like this. It will be at this point now, and it will lift up now 1 mm. So every time the tool is lifting up 1 mm. So this is the retraction amount. I hope it is clear to you. So sometimes the retraction will be in this way. Let us say it is removing the material and retracting the tool like that. Or sometimes the retraction will be in this way also. That is, it is retracting back in this taper direction. So both are correct. After that, we have starting block of the profile, P. Now we know this is the profile which we are going to achieve here. And let me define some values, some points here. Let us say this is point number 1, this is point number 2, 3, 4, 5, 6, and 7. Because the profile is changing here. This is, let me take another color. Point number 1 to 2, we are going in a taper direction. Okay. And then point number 3, 4, this is 5, and 5 to 6, we are going in this way. Then from 6 to 7, we are going linear direction. So now starting block of the profile, we are defining with this point 1, and finishing block of the profile, we are defining that this is the profile is finishing here at 7 number point. So these are the P and Q values. Now I will explain you this when we will write the today's program, that P and Q we will take 1 digit. We can also take 1 digit, 2 digit, 3 digit. That after P we can take P1 or P11 or P111. So it depends upon us. So after defining this P and Q, another thing that we have is U and W. So U is finishing allowance in x-axis. Now let us say we are going to reduce diameter, and you can take this diameter of some particular value. Let me take this as 25 mm. And at point number 1, let us say diameter is now 15 mm. Let us say. So it means now we are going to remove the diameter from 25 to 15 mm. Now, if we are going to provide some finishing allowance here in x-axis, U we are taking finishing allowance in x-axis, then let us say I'm providing finishing allowance as 0.5. Okay, U 0.5. Now it means that we are now removing the material from 25 to 14.5, because it will keep 0.5 material in the diameter, so that that particular material 0.5 material will be removed in the finishing cycle. And the same thing applicable for W, that is the finishing allowance in Z axis, which we are taking with W. And if we are taking here, let us say 0.1, so we know that the tool is going from this Z value 0 to this particular Z value, from here to here. It is taking a certain Z value. So instead of going up to this point, it will go, let us say this length is 30 mm. Just to understand, I'm taking a random value just for the sake of understanding the concept. So it will not go up to 30, it will go up to 29.9 mm, because 0.1 mm it will kept for finishing allowance, for finishing operation. So this value is our finishing allowance in Z. This is the Z length, okay, Z direction, and this is the finishing allowance in X axis. So U2 we are taking here for finishing allowance in, let me change the color, U2, this is U2, this is the finishing allowance in X axis, and W is the finishing allowance in Z axis. After that we have F. F stands for feed rate, which we can take in mm per minute or in mm per revolution. Now I hope all these parameters are clear to you, that the parameters which we are taking in G71 cycle. After this, I would like to mention one thing over here, that if you visualize this figure here, the diameter is continuously increasing from point number 1 to 2, 2 to 3, 3 to 4. If you check your diameter value, then the diameter is continuously increasing. So such type of profiles are called as our monotonous profiles. Monotonous profile. So it is our monotonous profile. Or monotonous shape. But what happens, sometimes we have the profiles which are non-monotonous, where the diameter is increasing, then it is decreasing, then again it is increasing. Let me draw that type of profile for you. Let us say we have this particular profile. Now, if you visualize, let me take different points here. Let us say this is point number 1, this is point number 2, because we are going in a circular interpolation from point number 1 to 2, then we are going from point number 2 to 3 in linear direction. This is point number 4, this is point number 5, this is point number 6, then we have 7, then we have 8. So if you visualize this profile here, the diameter is increasing, okay, then it is constant, then it is decreasing, then constant, then again it is increasing. So such type of profiles are called as non-monotonous profiles. This is our non-monotonous profile. And we can use this G71 cycle for both the profiles, that for monotonous profile and for non-monotonous profile also. So for that, we have two types in CNC operations, that is type 1 and type 2. And in order to differentiate in between them, type 1 and type 2, we can use a Z value here, okay? we can use a Z value here. Okay. And here there is no need to use of Z value. Let us say I'm taking, let us say this is from point number 1 to 2. I'm going with some circular interpolation. Okay. When we are providing X value, okay, then we are giving some Z value also. Okay. And we are providing some radius value. So when we are including some Z value also, these are called as our type 2 profiles or type 2 machining. And for monotonous profiles, we generally use type 1 machining. So in type 1 machining, there is no need to use our Z value with the G01 or G02. Okay. The point is that we can use this G71 cycle for both the profiles, for monotonous profiles and for non-monotonous profiles also. And for that, we have type of machinings, like that is type 1 for monotonous profiles and type 2 for non-monotonous profiles. So kindly keep this in mind. Now let me get back to the slide, this one. So I hope now all these parameters are clear to you. Now let us write the program. So O1008, this is the program name, as I already explained you this. These are the initial settings, G21 and G98. G21 stands for input in mm because the dimensions are here shown in mm. Then G98 is the feed in mm per minute. I hope this is clear to you also. Then this is the homing position. Okay. G28U0W0. After that, we are changing the cutting tool. M06 is the machining code for tool change. T03. Okay. T is the tool function. 03 is the tool number. After 03, the next 2 digits represents the tool offset. Then the next line we have M03. We are now rotating the spindle. M07, we are also making the coolant on here. Then S stands for spindle speed, 12,000 RPM. I hope up to here it is clear to you. Then we have G00, X26 and Z5. Now from the homing position, we are now bringing the tool at this location X26 and Z5. Since the diameter, total outside diameter of this workpiece is 25. So now we are keeping the cutting tool at X26. So this is our Z25 mm line. Here we know this is our X and Z value are 0 at this point. So Z5 will be away from here. Okay. 1, 2, 3, 4, 5. So let us say we are keeping the cutting tool from homing position to this particular point. So this is the location of the cutting tool. I'm just explaining you the location. I'm just locating the location. So from here to here now, as you already know, this is the starting of our profile. This is the starting of our profile or program. After that, now I'm using multiple turning cycle, that is G71. So U, that is the depth of cut in x-axis, I'm taking 0.5 mm. It means 1 mm material we are removing in each depth of cut. I hope you are getting it now. If I'm taking here 1, it means every time we are removing 2 mm material from the cylindrical workpiece. Then we have R. R is the retraction amount that we are, after taking some particular depth of cut and removing the material, we are lifting the tool up 1 mm. This is also clear, I guess. Then in the second line, we are using G71, which is a P1. Okay. So this is the starting block of the profile. I'm using here 1. You can use 2-digit value also, 10, okay? Or you can also use 3-digit value also, 100, because in some of the books you will find they are using 3-digit value over here. So all these values are correct. The only thing which you should keep in mind that I will explain you in the coming code, kindly just remember this, that I'm using P1 here after P1. Then Q2, this is the finishing block of the profile. Then we have U. Now U and W we are taking 0.1, which means the finishing allowance which we are taking here as 0.1 mm. So when we will remove the material, that means when we are reducing the diameter from 25 to, let us say, 15, it will go up to 14.9 mm, and it will left 0.1 mm for further finishing operation. So this is the significance of taking this finishing allowance. Then this is the W, which is the finishing allowance in Z-axis. Now, if you calculate this total length from here to here, it will be 4 plus 12, 16 plus 2, 18. Okay, 18 plus 12, it will be, this is your 30, then 8, 38. So it will go up to 37.9 mm, and it will keep 0.1 mm in the Z-axis. So this is the meaning of U and W. Then the feed which we are taking here in mm per minute, it means 70 mm per minute. Now I hope it is clear to you. After that, this is the starting of the block. Okay. So after in P1, I'm using P1 here. So when we will use N is the sequence number, as we know, or a block number. So starting block we are taking with N1. So whatever value which you will take here, kindly keep the same value here also. Now suppose I'm taking here P10, then kindly use N10 here. And if you are using, let us say, P100 here, you can use that also. Then kindly keep N100 here. So only this is the key point over here, that you can use 1 digit, 2 digit, or 3 digits, but you need to specify the same value after N. And then this is the Q, this is the finishing allowance. Finishing allowance I'm taking here, that is N2. If you are using 200 here yet, or 20 here, then kindly use the same value here. And in order to understand this here to here, because we know that this is from here to here, it is our this is our roughing cycle which we are using here. And from here to here, this is the profile which we are making. And in order to understand this in detail, let me open the slide for you, this slide. This is the same figure for which we are writing our program. And I have just marked some circles over here. Let us say this point is 1 here, this point is 2, okay, this is 3, 4, 5, and 6. So total there are 6 number of points here, and we know how we will move the cutting tool. From 1 to 2 it will move in this way, 2 to 3 it will move in this way, and then from 3 to 4 it will move in a radius R4 value, so it will be like this. Then from 4 to 5 it will move with the linear interpolation, then 5 to 6 it will move in this way. So this will be the tool path which I'm showing you here. And in order to find out the coordinates now, let me show you this table here. So the points we have here from 1 to 6, and X and Z value. That is, let us define some X value and Z value for point number 1. So for point number 1, our X diameter is how much? 15. Then Z is how much? 0. Because at this particular point we have Z0. X0 here, Z is 0. This is plus Z, and this is our plus X. Okay, and this will be our minus Z. This will be our minus Z with respect to this point. I hope it is clear to you. So In a similar fashion, now we are calculating all the coordinates. For point number 2, the diameter is how much? 17. And length is how much? 4. Since we are now moving towards the spindle, it will be like, we know this will be the spindle here. So we are moving towards the spindle in this direction. With respect to this point, it will be our -4. So 17 and -4. And code which we will use here, G01, G01, from point number 1 to 2. Then from 2 to 3, again with linear interpolation, and the coordinates for 3 will be, diameter will remain same, but length will be now 16. 4 plus 12, 16, it will be -16. All the values will be in -z. So in a similar fashion, now we will calculate the further values also, that is from now 3 to 4, the code which we will use here, since this is our counterclockwise direction, so we will use here G03 code. Okay, G03, and these are the respective x and z values, and for 5 and 6 also. Okay, if you locate the values of diameter and length, you can easily calculate. So these are the coordinate values for this profile, and we are now starting our profile from here. This is the initial block 1, and this is the end of the block. So I'm defining this as this is the starting of the block N1, and this is we are defining with our N2, that is ending is here. Now you can take N1 here and N2 here, because with the P value I'm taking P1, and with Q value I'm taking 2. Now if you are taking, let us say, P10, then kindly use N10 here, and if you are using Q20, then kindly use N20 here. I hope it is clear to you. Then let us get back to the slide here. So this is the same table which I was discussing with you. So after this N1, now you understand that why we are using N1. Now we are using G01, X15, Z0. Okay, X15 and Z0. So I'm using Z0 here. If you want, you can leave this Z value, because this is type 2 machining, and or this Z value we will use for non-monotonous profile also. So this is the difference between monotonous and non-monotonous, which means with monotonous profiles we can leave this Z value, because this is a monotonous profile. Here Z is increasing continuously. And when, let us say, we are dealing with some non-monotonous profiles, then we will use Z value here. So this is G01, X15, Z0. After that we have G01, X17, Z -4. Then we have G01 again, X17, Z -16. Okay. Then we have G03, X value, Z value, and then radius value 4, because this is the radius value 4 here. After that we have G01, Z -30. Okay, because X is same, so I'm not writing here X, you can leave that, Z -30. Then we have ending of the profile, that is N2. Okay, why? Because we are using 2 here with Q. So N2, G01, X25 and Z -38. X25 and Z -38. After this, now we are keeping the tool back to its home position. This is the home position, because we have now made the roughing cut on our this particular cylindrical workpiece. And after doing the roughing cycle and bringing the cutting tool back at its home position, we are changing the cutting tool, and now we are calling the next cutting tool, which is the finishing tool. Okay, so T01. Before we were using tool number 3, and now we are calling tool number 1. Let us say it is our turning tool for finishing cycle, and this is the tool offset. Then we are now rotating the spindle with 1500 RPM. RPM I'm using more here because we are doing the finishing operation. So we can use higher RPM for finishing cycle or for finishing operation. Then I'm calling the cutting tool at the location X25, Z5. Okay, it means it will be at X25 and Z5 at this location. After that, yes, after that I'm using this G70 cycle. This is the finishing cycle. Now I'm using my finishing cycle from starting of the block to ending of the block, P1 and Q2. So again and again, I'm saying if you are using here P10 or P100 or Q20 or Q200, kindly specify the same value over here also. Okay. So this is the finishing cycle. Now the cutting tool will come and it will perform the finishing cycle with respect to these allowances 0.1 and 0.1, because this 0.1 in X is we have kept, it is already kept in the roughing cycle, and 0.1 in the Z axis. So the tool will come and it will remove 0.1 mm material and do the finishing cycle. After that, we will now keep the cutting tool at its home position again, and we will off the spindle, and we will also, this is the coolant off, we will make our coolant off also, and M30, this is for program stop and rewind. Okay. So I hope now this program is now clear to you that how we will use G71 cycle for stock removal or for roughing cycle, and after that how we will use G70 cycle for finishing cycle. Now let me run the same program for better understanding in simulator. So this is the CNC train simulation system, as you already know. On the left hand side, I have written the same code which I was discussing with you, and this is the cylindrical workpiece on which we will perform our rough turning cycle and finishing cycle. So let me run this program for you. Now cutting tool is coming from its home position and removing the material from the workpiece. Let me increase the speed. Yes. So since this is a rough cut, so you can visualize some staircase effect here. Okay. Here the length is changing. Now after rough cut, tool is going back to its home position. Now the next tool is coming and it is performing the final finishing operation. See. So after that, the tool is going back to its home position, and this is the profile which we were looking for. Now I hope this program will be clear to you that how we will use G71 cycle, that is multiple turning cycle, which is also called as stock removal cycle in turning or roughing cycle. And after that, how we will use finishing cycle. If you face any difficulty in this video lecture, you can comment me on the comment box of this video lecture, or you can email me, which is mentioned here. So thank you so much for being with me in this video lecture. Now let us meet in our next video lecture. Thank you so much.